Hello, this is MacMaster4848 here, and this video is the third episode of a series that's recently started called the Tech Dictionary. Now this episode is about the internet, as you might have guessed by reading the title, which you are seeing right now. So anyway, first thing to talk about is the definition. That's one of the most important things about it, to know how it works. So anyway, the internet is a global system of computer networks interconnected. So basically that means that many companies run their own networks, research companies run their own networks, basically lots of people and companies and businesses run their own networks, and they all connect them together. So I'll explain that in more detail later. So anyway, there are many internet protocols that exist, such as VoIP, which is voice over IP, used for things like Skype, for example. There is FTP, file transfer protocol, and SSH, which is used to remote control many different servers and things, and many other internet protocols. I think even some things have their own protocols, such as Skype. So also, every device connected to the internet has a unique address called an IP address, which stands for Internet Protocol, but most people just call it an IP address. I've never heard anyone just say Internet Protocol address, but maybe it could be more formal. So anyway, and there are also DNS servers. So DNS servers are quite important in the internet because, for example, when you type in google.com, then you connect to a DNS server which tells your computer or your web browser the IP address of the server to connect to. Then you connect to the IP address. Also internet connections are often given by ISPs. Basically most home connections are connected through an ISP, but for example data centers, large companies, etc. don't connect to an ISP, they just connect directly to the internet, some internet network, or just the internet backbone. Anyway, if you use an ISP, then you're probably connected to a local exchange, then the local exchange connects to the ISP network, and it's best to use a local exchange, internet exchange that has an LLU, and use the ISP that supports the LLU. It's just quite a good tip. Basically you get quite good internet using an LLU. So anyway, how do we connect to the internet? So this is just basically some steps of what happens. So basically a computer has files stored in bytes, you might already know that. However, a computer sends and receives many packets with a few bytes stored in each packet to a router or a modem, whatever. Then it submits it basically through the internet to the destination of where you're sending and receiving it to or from. So then, as I already said, the router or modem sends packets through a wire, cable, and basically someone receives it. And the exchange basically sends these through an ISP. So, for example, if you're downloading or uploading something to a website, then you sending or receiving packets from a server, or if you're just talking to someone through instant message, then it's just directly to the other computer. So it's through your ISP and the other person's ISP. So so many networks connected together? It is quite amazing how many networks connected together. That basically a large percentage of the world is just covered by these enormous networks. So the internet is not a large server. There is a TV show called IT Crowd, where basically someone is basically told that the internet is a box. It's quite funny. Anyway, basically, what is quite amazing about the internet is if a cable is damaged, it's very unlikely that the whole internet is affected. If any area other than the area where the internet cable is damaged. Only the local area is affected. Also, ISPs, companies, schools, universities run their own networks. Now, of course, separate homes might not connect to these networks, but they can be used just for the building. For example, university might have their own network just used in the university. And then this connects directly to the internet and all the other networks. and also the network. Basically, people that run networks, large networks, often agree to connect the networks together. However, there can be local networks, like you can technically start your own internet if you want. However, the scale of it will be quite a bit smaller. So networks can be run locally, like I just said. Someone wanted to, they could create another internet just for the city, country, or just for one more friend. And also, people can create or connect to a network from anywhere in the world. So, for example, one person can live somewhere, and another person on the other side of the world can also connect to the network. So basically, how this works is that you can use a VPN. So basically, it connects to the internet or to the network through a computer somewhere, which is likely in another country. So, free example of this is Hamachi. However, most VPNs are not free, and Hamachi is also very slow. VPNs slow down the internet connection a lot, and also most VPNs or paid VPNs encrypt the data. So, can others view my packets? That is send, receive. Now this is true unless you encrypt it. But I'll explain this in more detail right now. So ISPs or network administrators can use something called can be called DPI, or Deep Packet Inspection, and see everything you do on the internet. So for example, if you torrent something, then your ISP can find out what you're torrenting, etc. But of course, the amount of people downloading things means that it is quite hard to do this currently. However, a deep packet inspection could be automated. And what I mean by suggesting torrenting, I'm not suggesting that it isn't a legal thing, but it can be used for copyrighted content, such as anything on the internet, including YouTube video streaming. So anyway, basically, even people connected to the same network as you, not of course through the internet, but people connected to the same router as you, modem, can see all the packets that you send and receive, unless of course you encrypt everything. So packets store information such as what protocol it uses, the IP address, etc. So packets can't really be sent to the wrong person, and anyway, that's quite unlikely to happen. So packets can be encrypted, as I've said already. So you can use your own encryption methods, I think, but why not just use an existing encryption method that hasn't been cracked before. So many websites now use something called HTTPS, Hypertext Transfer Protocol Secure, which encrypts most of your internet usage on that site. So for example, internet banking uses HTTPS, etc., so that people cannot just basically be in the same network as you and find out all your passwords and everything. You can also use VPNs to encrypt all your internet usage. However, of course, this doesn't mean you can do whatever you want on the internet without anyone knowing, because quite a few VPNs do log the usage, and also payment details, etc. are logged also. So also free VPNs exist, such as Tor. However, they do slow your internet connection down quite a noticeable amount. So what is an IP address? An IP address is basically a unique number given to all devices connected to the internet. It doesn't mean that, for example, I think currently about 3 or 4 billion IP addresses are used. That doesn't mean that many people connected to the internet currently. It just means that, for example, a company can be given like 64 IP addresses, and that doesn't mean that 64 people are actually using them. So there are two main IP versions currently at the time of making this video, IPv4 and IPv6. Now IPv4 is quite old, but takes a while to transition from. So currently it is used for most of the internet at the time of making this video, January 2012, no, February actually. However, IPv4 is limited to 4.3 billion IP addresses. So basically this means that this doesn't mean that that amount of people connect to the internet, as I've said already, but for example universities can be given a large amount of IP addresses, and they might not even use all of them, but other people cannot use them. It is possible to, like currently, the companies that give IP addresses to people are trying to limit how many IP addresses give to companies. Many companies, sites, ISPs, etc. are slowly transitioning to IPv6 addresses, which has many trillions of possible IP addresses, which sounds like that will be enough for a long time. However, they will just be given to so many people, so many large amounts will be given to just a small amount of people that could actually be used quite quickly. However, trillions is quite unlikely, even if every single person is given about 10 or something. So anyway, blocks of IP addresses given to ISPs, etc. I've said that already. Also, website or dedicated server hosts give IP addresses to most servers. However, someone might need to pay extra for a dedicated IP address. ISPs give most people dynamic IP addresses, meaning they change every few days or each time you turn off the router for a certain amount of time. Normally for at least 5 minutes up to 24 hours most of the time. However, some ISPs do let people have static IP addresses which do not ever change, which might be a good idea if you don't want to be affected much by the IP address shortage. However, this will not solve the problem for other people. What is a server? A server is quite a major part of the internet. Basically, all websites, everything, game servers, programs such as instant messages, etc., download servers are all hosted on servers, as I suggested by saying download servers. Servers store data such as HTML, PHP web pages, Flash, etc. There's just endless lists of what they can store. And also process data using PHP or MySQL, etc. if you have a website that supports those things or actually uses those things. So for example, PHP lets you use things like login systems, etc. Many servers run an Apache. However, there are alternatives, but Apache is used by most web servers and is probably one of the most stable web servers. Also quite a good tip is if you want to run a web server, it's best not to use Windows, and also for price reasons, Mac, it is best to use Linux or possibly Ubuntu server, because it is most secure and least likely to get a virus, because hackers often attack servers, because servers can have many things in them, such as passwords, etc. A lot of valuable information. Servers can be run from anywhere. However, they do require a good internet connection, at least 100 megabits per second internet connection, and most hosting that you can actually rent hosting, which is somewhere else with a good internet connection, and they'll normally give you about 1 gigabit per second internet connection if it's good hosting. It requires to be connected to the internet backbone if you want such a fast internet connection. So it's not a good idea just being connected through Exchange. And also ISPs can take away internet connection if they don't like you running a server. So anyway, what is a web browser? Now, a web browser is basically where you are likely viewing this YouTube video. You might already know a bit about web browsers. However, a web browser is a software application that retrieves and displays files on the internet, such as HTML, PHP files, many other things. The list is endless again, like I said earlier. The destination of the web page or file you're viewing is basically in the URL. So for example, if you go to google.com, that's a URL. However, this is shortened. Normally it's http:// that's a protocol. Then it's www, which stands for World Wide Web, which web browsers don't require you to type anymore. Then it's google.com or something like that. Quite a widely used example, Google. I think actually Google is more used to test people's internet connection over searches. I think that's quite an interesting fact. So anyway, URL can be a domain name or it can be an IP address. They're both the same thing, except domain names connects to an IP address automatically through a DNS server. Web browsers can also be used to view local files on your computer, or if you have a network. So you can have a network that's basically like a home network, company network that's not connected to the internet, and you can still host your own websites, etc., and use web browsers. And quite a few web browsers at the moment support extensions and add-ons such as Adobe Flash Player and many other extensions such as Adblock Plus, many other ones, and they also the main web browsers currently are Mozilla Firefox, Google Chrome, Apple Safari, and also Opera, and there are a few other web browsers also, but those are the main ones. And Internet Explorer, just for your info, is likely the least secure web browser. So if you're using that, it's best to upgrade Google Chrome, something like that.
What is EDI? EDI stands for Electronic Data Interchange. It's a protocol maintained by the American National Standards Institute used for the computer-to-computer exchange of business transactions and business-to-business information exchange. Really, to understand and appreciate the value of EDI, let's see how a transaction such as a purchase order is exchanged without EDI. Although the purchase order may start out as electronic data as shown here, along the way it might be printed to paper, then manually retyped into the receiving party's business system. It's easy to see the inefficiency and potential inaccuracy of all these manual steps, especially when data must be rekeyed. With EDI, it allows businesses with two different business systems to use a common language to talk to each other. By automating the process, human interaction is minimized and delays and mistakes can be greatly reduced or even eliminated. Here's an example of the purchase order that has been converted to the EDI format. If you look closely, you'll find 25 items that charge $1.55 each, with a list price of $3.99 each. They are going to be shipped to the retailer at Global Distribution Center. The item ordered is referenced by a UPC code and a corresponding SKU number. This format is not ideal for reading by you or me, but because it has been converted to the EDI protocol, it provides a very efficient and accurate way of exchanging this document between two different computer-based business systems. There are hundreds of business documents that can be electronically transacted via EDI. Here are some common EDI document types. Purchase orders are used to initiate an order. Invoices are sent to request payment. Advanced ship notices, or ASNs, let a company buying products know when and how their items will be shipped. ASNs often include barcode information that indicates specific items in this box. Functional acknowledgments are simple but highly beneficial transactions that confirm the date and time the document transmitted via EDI was received. Imagine no longer having to wonder when you'll be paid for an order because you'll know exactly the day and time your customers received their invoice. Therefore, the benefits of using EDI range from expediency and efficiency gains to being able to conduct business with the largest, most influential businesses in the world. To successfully implement a fully integrated EDI solution, 4 components are required. Here we have 2 trading partners who need to exchange business documents using EDI. On the left is the supplier and on the right is their customer, a large retailer. First, they need to be able to automatically move transactions to and from their backend in business or financial software without having to retype it. This is called the integration. Data mapping software ensures that the EDI data being pushed and pulled appears in correct places in all of the documents. Second, translation software converts those documents and their data to and from the EDI standard. Third, just like a cell phone, a secure and reliable network is needed to be able to exchange EDI transactions with trading partners. Finally, the 4th component, which is often overlooked, is the support and maintenance required to implement an EDI system and keep it running. In a traditional EDI solution, each of these components are sourced through various providers that specialize in providing one of these services or software products.
Security is one of the most important aspects of an e-commerce business. For an online store, being able to gain a customer's trust should be top priority. If you are unable to protect your customers' personal data and credit card information, then you can forget about doing business online. Your job is to provide safe web browsing and secure transactions. In order to provide your customers with the safest possible online shopping experience, there are 3 main security features that your e-commerce site cannot be without. They are secure hosting, SSL encryption, and PCI compliance. With these 3 working in sync, your online store will have heavy-duty protection, which will enable customers to have full confidence in making purchases. The first thing you need is secure and reliable hosting. Without it, your e-commerce website will not be able to run smoothly. It's important to have plenty of bandwidth to handle potential floods of traffic, large disk space to store unlimited products and customer information, a strong firewall to protect important data, and the host provider must guarantee an uptime that is as close to 100% as possible. SSL encryption provides security over networks. It's basically a system that codes and decodes sensitive data such as the customer's personal information or online transactions to protect it against hackers. E-commerce solutions typically provide 128-bit encryption, which is already very secure, but some offer 256-bit for added protection. PCI compliance is a standard which was created by major players in the credit card industry in 2006. It ensures that all online businesses that process, store, and transfer credit card information do so in a secure environment. In order to become PCI compliant, you must be able to build and maintain a secure network, protect cardholder data, maintain a vulnerability management program, implement strong access control measures, regularly monitor and test networks, and maintain an information security policy. What you need is an e-commerce solution that offers daily backups, has close to a 99.9% uptime, provides state-of-the-art firewall protection, has a data center with great backup generators, offers real-time protection monitoring, uses either 128 or 256-bit SSL encryption, and is fully PCI compliant.
Good marketers aim to understand their customers' behavior, wants, and needs. But are they able to put this information into action, promoting the right thing at the right time, at the right place? Until now, you had no way of directly applying your knowledge about your customer behavior. You can see what is typed into search engines, which can provide a basis to predict what the customer wants. The problem is that you can't merge this with predefined target groups A, B, and C and expect them to behave as such in all contexts. Life doesn't work like that. You may know the impact of the weather, the time of day, and location on the customer's behavior. Now, SDL Tridion blends data from a whole range of external sources like these, really taking context into account, promoting the right things in the right way at the right time. Just think for a moment. Why are landing pages so successful? It's because you've pre-selected the audience and you've connected them to a site that you believe is completely relevant to them at that moment. What SDL Tridion can do is make every page you manage just as relevant. SDL Tridion combines fundamental information like the customer's journey, behavior, and patterns in a self-learning system which takes the crowd behavior into account. This means SDL Tridion also uses information like ratings, reviews, external data, and shopping behavior and merges all that knowledge with your business goals and your segmentation rules. All that powerful knowledge is then automatically offered in line with the wants and needs of your customers, making targeting and personalization easy.
For many businesses, it is becoming increasingly difficult to manage your business listings online. And with the growth of sites that encourage ratings and reviews, it's even more difficult to ensure your business reputation is managed effectively. This could mean you or your staff need to log in daily and check each of these sites to ensure there was no negative feedback from your customers. This is exhaustive, to say the least. And who has the time in business to do such a task on a daily basis? That is where local search management by BlueBiz comes into the picture. This sophisticated system will monitor and optimize content on all the major sites like Google, Yelp, TripAdvisor, Foursquare, Urban Spoon and more to ensure that any feedback left for your business is dealt with immediately. So how does it work, you ask? Local search management is about making your business look good on all these sites and also closely monitoring any customer feedback, real time. As soon as any negative feedback is found, it is immediately reported and responded to. This achieves 3 major goals. It shows new customers that you care about what your customers are saying, that you actively communicate with these customers, and gives the real possibility of getting negative feedback removed. When one piece of feedback is left against your business online, it could be seen by hundreds or thousands of potential customers. Don't let bad feedback undo all the good work you've done in your business and potentially cost you large sums of money. Manage it effectively today with Local Search Management by BlueBiz.
Do you have a website? Do you want to have a website but not sure how to add stuff to it? Do you know that there are applications that can turn you into a website guru? These applications are called Web Content Management Systems, or WCM for short. There are hundreds of web content management applications, but it's important to pick the right solution for your needs. This is web content management made simple. Typically, websites are set up on web servers by people who are familiar with coding languages like HTML, PHP, ColdFusion, or .NET. You can leverage people with this technical skill set to get your website up and running. People can now come to your website, learn about what you do, interact, and maybe even purchase a product or two. But the information that they're consuming is quickly becoming out of date. But what can you do? Meet Tom. Tom is the marketing guru at his company. He knows all the ins and outs of marketing, but he really isn't that technical. Tom needs to fix a typo on his website. He could call or email his web guy, but he usually doesn't pick up the phone and tends to be busy doing other web stuff. Making a small spelling fix isn't at the top of his priority list, and it doesn't really pay his bills. If Tom had a web content management system, he could make the fix himself. Tom could open a browser, log into his site, browse to the page that has the typo, edit it, and publish it back to the site. Tom doesn't know HTML, but that's okay because his CMS includes a what you see is what you get or WYSIWYG editor. A WYSIWYG editor makes editing a web page as easy as creating a Word document or writing an email. Tom can even add photos and links to the page as well. Now that Tom's website is updated, his visitors are happy, but more importantly, Tom is happy. Web content management systems come in 2 different flavors, online and offline. Offline systems require you to make changes to your static pages on your local machine and then FTP those files to your server. This requires some technical knowledge, it isn't scalable, and it really chains you down. An online CMS, like the one that Tom wants, is completely browser-based and managed by a database that stores and displays information on your site. An online CMS lets anyone, from anywhere, at any time, make changes to their website. A CMS typically can do more than just help you manage your web content. Some have advanced management functionality like permissions, workflows, and approval chains. What is web content anyway? There are some that do more than just managing HTML content on your site. There are some that let you manage and create digital assets, documents, and even build pages quickly and easily right on the web. Some also have out-of-the-box functionality to power and execute comprehensive and complete digital marketing strategies like SEO tools, Web 2.0 functionality, social networking, and e-commerce. Are you a developer? It's important that you pick a CMS with an open API to easily extend and customize your website. What do you want your website to do? Odds are there's a CMS out there that can do everything you want to do on the web and more with just one application. Making sure your CMS can do everything with just one application instead of 20 different modules will make sure that your site is up quicker and much easier to maintain. Since Tom was able to fix that typo on his website pretty easily, he wants to announce the sale of his new product. Since Tom's CMS has page building feature built in, he can now create new pages by simply dragging and dropping page elements onto his page, like multimedia, 5-star ratings, a message board, and even a form. Site visitors can now interact on Tom's site, and Tom didn't even need to know a line of code. There are hundreds of WCM systems out there to pick from, and choosing the right one is crucial. A WCM can be provided as a software as a service, open source, or as a standalone application. If you don't have much money up front, an open source can work, but you'll pay the price down the road when you need support or help upgrading your site. Picking an enterprise or mid-market CMS from a reputable vendor is well worth the investment. CMS vendors have engineers working around the clock providing high-quality product, and some provide phone support to help you with your site. Purchasing a CMS is like purchasing a car. You want to make sure that you get all the bells and whistles you want, but still keep it at a price you can afford. Let's recap. Web content management systems let non-technical people, like Tom, create and manage content and pages for their website. Some let you make changes from anywhere at any time, and some have everything you want to do on your website with just one application. There are tons of WCM products available, and choosing the right one for your needs is crucial. Answering the question, what do you want your website to do, is a good start.
Workflow management. Visualized. What is workflow management? Ask your typical college professor and they might tell you something like, workflow management is the automation of a business process during which documents, information, and tasks are passed from one participant to another for action according to a set of procedural rules. What? Let's see if we can clarify that a bit. Workflow, at its core, simply refers to the process of procedures in which tasks are completed. Often, workflow is used interchangeably with terms like business process management and process reengineering. Essentially, all these terms are concerned with the same thing. They all refer to the way work flows through an organization. Think of work like a boat flowing on a current downstream on its way to some ultimate destination. Alright, simple enough. So what's the big deal? Well, workflow is important because it affects processes. And processes are everywhere. Let's take a look at a couple common processes in a typical organization. For example, a job opening is posted. An employee is hired. An incorrect bill is received. Money is refunded. A loan application submitted. And a loan is funded. The big question, however, lies inside of these arrows. What is happening between the actions on the left and the results on the right? Most processes include many steps, information handoff, and interactions between different people in different departments of an organization. This complexity can lead to inefficiency, inconsistency, increased risk, and impaired productivity. So as an organization, we need to ask ourselves, are we operating as efficiently and effectively as possible? Or, to put it another way, is our boat floating along smoothly? Oftentimes, the answer is no. This is where the management and workflow management comes in. The goal of workflow management is to understand and determine what tasks need to be executed, what order they need to be accomplished in, who is involved, what systems are being used, and what rules are being followed. Without this proper management, our analogy turns from a boat floating down a calm river to salmon vigorously fighting to swim upstream. To demonstrate, let's take an example from an industry that many agree is in dire need of workflow management overhaul. Healthcare. Ideally, here's how a typical billing process would work at your average doctor's office. The doctor here provides a medical service to a patient. The doctor sends off the necessary paperwork to the insurance company. In turn, the insurance company receives the paperwork and sends payment back to the doctor. The doctor has the money, the patient is feeling better, and everyone is happy. A smooth, easy process, right? Potentially, but without proper workflow management, things can go very bad, very quickly. Let's take a closer look inside the workflow and see how this scenario often unfolds. We're going to move fast here, so try to keep up. The patient arrives at the doctor's office and fills out an information form. The front desk, in between answering phones, dealing with patients, and filling out other paperwork, eventually places the form in the patient's chart. When the patient is ready to be seen, the doctor pulls the chart, provides the medical service, and fills out a fee ticket, which he returns back to the front desk, who of course is still answering phones, dealing with patients, and filling out other paperwork. It's now the front desk's job to manually enter the fee ticket information into the computer, without errors hopefully, and then convert the fee ticket into a claim form to be sent to the insurance company, via old-fashioned snail mail. Offices deal with many insurance companies, so hopefully it gets sent to the right one. If not, it'll be returned right back to the doctor's office. Now these claim forms can be quite complicated, so even when the claim form is sent to the correct insurance agency, occasionally you'll be missing information or not properly coded. Was that procedure actually covered? Did the doctor check the wrong box on the form? If so, it gets sent right back to the doctor's office again. Now, assuming everything goes perfectly and the correct insurance company receives the correct claims form, the insurance company is now able to send a payment to the doctor in the form of a paper check, of course, via old-fashioned snail mail. With a little luck, though, the check arrives at the front desk, where as usual they are still busy answering phones, dealing with patients, and filling out paperwork. And if they're not too busy at the time, they can post the check data into the computer and prepare the check for deposit. Just as likely, however, the check will be placed in the no time to deal with the now file cabinet, or, as large stacks of paper are prone to do, accidentally find its way into the nearby trash can. In the meantime, though, the doctor is left wondering where his money is. Did he fill out the fee ticket correctly? Did the insurance company receive the claim form? Are they disputing our claim? Is it lost in the mail? Was there a key punch error? Was the check lost at the front desk? All this results in an unhappy doctor, an unhappy patient, and a poorly run office, all relying on a business process in need of a serious workflow overhaul. A process that should have resembled this ended up looking more like this. Though it may seem ridiculous, this scenario is actually quite common. In fact, it's estimated that poor workflow results in doctors only receiving payment for around 60% of what they bill for. Clearly, there is major room for improvement here. Now let's take a quick look at a second doctor's office and see how they operate. In this doctor's office, the patient fills out their information at a kiosk in the lobby, and the data is sent directly to the doctor's laptop. As the doctor is performing the medical service, he enters the billing information directly into his computer, where it's sent electronically to the proper insurance company. The insurance company instantly processes the information on the form, sends a confirmation email back to the doctor's office, and makes payment instantly via an electronic funds transfer directly into the doctor's bank account. Quite a difference, huh? Which of these doctor's offices operates more efficiently and more effectively? Which one is more committed to workflow management? The answer is clear. Of course, workflow management does not just apply to the billing process in doctor's offices. As all organizations grow, they face the challenge of managing, maintaining, and scaling their business processes. In today's economic environment, businesses need to be able to adjust quickly when it comes to optimizing operations. They must figure out new ways to raise productivity, lower costs, increase ROI, and more effectively meet the needs of the consumer. To address these challenges, many organizations turn to workflow management.
In this video, we will learn about an important design pattern known as notification. A notification is a message sent to one or more observing objects, informing them of an event. A notification is a message sent to one or more observing objects, informing them that an event has occurred. The centerpiece of the notification mechanism is a singleton object known as the notification center. When an object posts a notification, it goes to the notification center, which in turn broadcasts the notification to all the observers. The observers have to first register with the notification center to receive the broadcast notification. Also note that when the object posts a notification, it is sending a class known as NSNotification. More on that later. The notification broadcasts are sent synchronously, which means that the object sends a notification and waits till it has been received by the notification center. On the other hand, you can send notifications asynchronously, buffering up your notifications in an NSNotification queue.
We have all been there. You're at your desk struggling to get through the hundreds of emails in your inbox to find the ones that are really important. The senders are expecting a response today, and you feel the pressure to please the people you work with. It's enough to keep you up at night. There's a monster that lives not in your closet, but in your inbox. In an effort to stay on top of the inbox monster, you organize senders into lists, put pretty little tags on messages, and rush to answer them, hoping to get back to what it was you were doing. Responding to email now makes up over 2 hours of the average worker's day. Because of the burden of the email monster, communication suffers. You send emails that get skimmed, ignored, or deleted. Some of them are flagged as spam and get lost in the abyss. Other emails are forwarded and the important attachments disappear. Sometimes it takes ages to get a response to the simplest of questions. While the rest of the internet has evolved, email is pretty much the same as it was 10 years ago. Isn't it time to get out of your inbox? Suddenly you see a beacon of light that will free you from the dark caves of the inbox monster. Picture this. Everyone you work with is connected to you in a common area to communicate. Not only that, but now your group can delegate tasks, collaborate on ideas, edit content, manage projects, or just send status updates. The whole team is able to access this content from email, mobile apps, RSS, and anything else we come up with in the 21st century. Everything you need is centrally located and easy to find. Anyone you want to start working with is a click and a welcome away. It's so simple now. The way you work is forever changed. This is what Teambox can do for you.